In this video, we'll have a look at the options available to you in the 3D Finishing Toolpath. We will also demonstrate a practical use in conjunction with an already created Roughing Toolpath. If you've not yet watched the tutorial called How to Use the 3D Roughing Toolpath, we suggest you do this before this video. There will be a link in the related videos section to this tutorial. Although it is not always needed to have machined or cut a 3D roughing toolpath before you run a 3D finishing toolpath, it is the most commonly used workflow. A 3D finishing toolpath is used to remove the machining allowance left by the roughing toolpath, revealing the detail of the 3D carving. The 3D roughing toolpath does the work to remove the lion's share of the material using a large cutter before the 3D finishing toolpath goes in with a smaller cutter or a combination of smaller cutters to do the rest of the work. Okay, before we get started, let's have a look at a roughing toolpath to help us cut this 3D model. Let's jump right over to our Toolpaths tab, and we'll take a look at our 3D roughing toolpath. Again, like I mentioned in the intro, if you haven't yet looked at our How to Use the 3D Roughing Toolpath video yet, I highly suggest you have a look at that before you go on any farther, because I'm just going to give you a brief overview of how to use this toolpath. So first of all, we're using a 1/4 inch end mill. Now that's a bigger cutter than we plan on using for our finishing toolpath. We're going to make sure that we limit our cut to a model boundary. We're going to leave a boundary offset that's equal to the diameter of our cutter. That way we have room for our smaller cutter to fit in between our actual 3D part and the wall of our material. We're going to leave behind a 0.04 machining allowance, and this is the machining allowance that our 3D finishing toolpath will go in and remove. We're going to use a roughing strategy called Z-level roughing. We're going to profile last. We're going to go level by level. We're not going to use a raster angle, no ramp or plunge moves, and we're just going to go ahead and simply calculate that. If we preview that visible toolpath, you'll see what we get once we end up cutting this on our CNC machine. And that looks like exactly what I would expect to see. A very rough looking toolpath. And now we'll go in and create a 3D finishing toolpath to help reveal that finer detail of this 3D model. I'm going to start off by closing down our preview toolpaths. Now the 3D finishing toolpath is located here. If we click on that, we're brought straight to all the different options that we have to choose from for the 3D finishing toolpath. First of all, we're going to see that we can choose a tool or several tools. For right now, we're just going to use one tool. In this case, it's going to be a 1/8 inch ball nose. You can select a different tool if you'd like to from your tool database. If you want more information on how to use your tool database, there'll be a related video linked below for you to have a look at that. For now, we're just going to close this down because we're going to go ahead with that 1/8 inch ball nose end mill. You can also choose to remove a tool if you'd like to, or actually edit the tool temporarily for this toolpath. The next section we have to choose from is going to be the machining boundary limit. Now, just like in the roughing toolpath, we can choose from different options for this. Probably consider using the same option that you used for your roughing toolpath, if indeed you have one. For now, I've got the model boundary selected, so the software will find the boundary of your model or models that you have in your composite view. You can choose the material boundary, which will be all the way up to the edge of your material or job sheet. You can use a selected vector. So if you had a vector in your 3D view, you could select that along with your 3D content, and the finishing 3D toolpath will be limited to the selected vector or vectors. You can choose a selected level. So if you have all of your 3D content that you'd like to include in your 3D finishing toolpath all put on its own layer, you can choose that from here. For now, we're just going to go ahead and use the model boundary. We also have a boundary offset. In this case, we're going to use the diameter of our tool as our boundary offset. So that will go past the edge of our model, in this case 0.125 of an inch. That will, in the end, alleviate some of the cusping you might get around your project or around your model if you do indeed want to cut this out. We're not going to look at the rest machining section right now because we only have one tool selected. We'll look at that in a little bit. We have a couple different strategies we can choose from. We can run our 3D finishing toolpath through an offset tooling, which will start in the middle of your job and work its way out to the edges. You can choose a cut direction of climb or conventional. We have a Stepover Retract that we can include in that, and we'll take a look at that in just a second. Now if we choose the raster option here, that's where the tool will actually go back and forth across your model. We have the option of a raster angle we can include in here. For now, we're going to go back to our offset option. We also have a reminder of what our safe Z is in our home position, and these are safe and appropriate for my machine. You have a option here of using the automatic vector selector. If you'd like more information on that, I'll also put a related video below to help you with that. For right now, we're just going to leave the name as it is, but you can choose to name it whatever you'd like to, and we can calculate that toolpath. Now, as you can see, we have our 3D roughing toolpath still previewed. And on top of that, we can go ahead and subtract the 3D finishing results from that. So let's go ahead and preview that visible toolpath and we'll see what we get. Again, working from the inside out, you'll see that it cleans up that 3D model nicely and we get a good result in the end. You can also see the boundary offset here for that tool. Our roughing tool went all the way out 1/4 inch and our finishing tool only went out 1/8 of an inch, and it's gone down all the way past that machining allowance that we left behind. That's why there's that little step there. Now let's have a quick look at that toolpath for a minute. If we zoom in, you'll see that the tool will actually do one loop and then move out and do the next loop and then move out and do the next loop. You may notice there'll be a slight witness mark left behind. If you see that, then we can go and take advantage of that Stepover Retract. If we undo that last toolpath and we take a look at our 3D finishing toolpath again, let's add in a slight Stepover Retract to be 0.025. And if we go ahead and recalculate that, you'll see that now we're going to have in our finishing toolpath slight retracts here. Every time it does a loop, it's going to retract, move over, and do the next loop, and so on and so forth. And that will hopefully alleviate some of that witness line of your tool moving across your finished part. Okay, let's just go ahead and preview that visible toolpath again. You'll notice that the 3D preview looks exactly the same as it did before, even with that Stepover Retract in there. That's because those witness lines are the result of something to do with your tool on your machine, not the software. Let's undo that last toolpath, and let's go back into that finishing toolpath again. Let's have a look at our raster option here. And we're just going to go ahead and leave the raster angle at 0, but of course you can type in whatever you'd like. And let's recalculate that toolpath. And you'll see that now the tool is going back and forth across our job. So if we go ahead and preview that toolpath, you'll see the tool going back and forth across the job all the way to the top. Okay, let's just close that down and go back into our 3D finishing toolpath. Now, the next thing we're going to have a look at is going to be adding in an extra tool for rest machining. So what rest machining will do is it will take your largest tool, your largest finishing tool, and go across to your part and then look at its results and see if it can add any extra detail or remove any extra material for a smaller bit that we may add in here. So if we go ahead and select another tool, we'll add in a 1/16 inch ball nose, select that. And then we'll just go ahead and look at the rest machining area. You'll see that we have an option for the minimum detail that we want to see. We can adjust it from coarse to fine. And then again, we can add in a slight boundary offset if we'd like to. And that will actually cut outside the areas that is trying to get extra detail. And this may help in merging together the results of the two toolpaths. For right now, we'll leave it at 0. For each of the tools that you've selected above, you can choose a different strategy. So keep that in mind, and you'll note that just beside the word strategy indicates the tool that you're choosing the strategy for. And let's just recalculate that toolpath. With rest machining, you may find yourself playing around with those settings just a little bit until you get the results that you want. Let's undo that last toolpath we just looked at. And you'll see now we have 2 extra toolpaths in our toolpaths list. We have a clearance tool and a finishing tool. If I turn off the finishing, you'll see that we have a nice full toolpath. This will go in with that 1/8 inch ball nose end mill and clean up most of the material. If we turn that one off and turn on our 1/16th, you'll see that it's going to go ahead once we change our bit and run the second toolpath, and it will get rid of some of the cusping that we saw around our job. So let's have a look at that. We're going to turn off this one and we'll preview our visible toolpath or our selected toolpath. That's the 1/8 inch ball nose end mill. And then we'll have a look at the results of the adding in the 1/16th. You see that it cleans it up around the edge. Now that might have been hard to see, so I'm just going to undo that last one for a second and just watch right in here. Play the selected toolpath. We'll slow it right down. You'll see it kind of working its way up, and it cleans those edges up really nicely with that small bit. Now you might find that rest machining is going to work really, really well for a 3D job that has lots of fine detail. You're going to want to go in with a bigger finishing bit and get most of that detail out of there, and then come back with a smaller one to show off some more of that other fine detail. And you can add in as many different bits as you'd like to that toolpath. Now with that, I hope you have a better understanding of how to use the 3D Finishing Toolpath.